Hello, so far we have completed geophysical methods, electrical resistivity, seismic refraction method, plate test, and SPT. The next in line is CPT, that is cone penetration test. Okay, now CPT is conducted into two processes. One is with the vibrations and without the vibrations. So when there are no vibrations or there are no blows onto the drive, okay, onto the drilling rod, then it is called static cone penetration test. And when vibrations are involved, it is called dynamic cone penetration test. If suppose there is no suffix attached and we say CPT results, it's fundamentally SCPT, that is static cone penetration. If there are vibrations attached, then CPT will always be prefixed by D, alphabet D, which stands for dynamic. Okay, CPT is also called Dutch cone penetration test. Okay, it's an in situ test. So on the site, this particular test is carried out. Okay, a cone penetrometer will be pushed inside the ground. Okay, at a rate of 1.5 to 2.5 centimeters per second, and the data that is collected is recorded at regular intervals. The cross-sectional area of the cone can be around 10 to 15 centimeters square, corresponding to the diameters of 3.6 to 4.4 centimeters square. Now, why do we need this particular test when there is already standard penetration test available? The reason being, the N values do not always represent the friction value of the soil. Why? Because see, when you conduct SVT, it's a static or dynamic test. If you remember, there are blows, hammer blows, which are given to the drilling rod, right? So when there are blows involved in any particular test, then the type of loading becomes dynamic. Now, when you conduct dynamic loading and you note down the various parameters, let's say shear parameters or frictional value, those are corresponding to the dynamic loading. Now, soil is not always under dynamic loads. Very seldom it is under dynamic load, right? So, these values which are reflected by N, okay, will not be applicable for soils which are under static loading. Okay, so there can be a little bit of discrepancy. Okay, SPT values, that is N values representing the penetration resistance of the split spoon sampler. If you remember what is split spoon sampler, it's that rod. This is a split spoon sampler. Okay, so SPT values or N values representing this sampler will be actually affected by two particular parameters. One is the skin friction acting around the surface, and second is the point resistance at the base of the sampler. And both these factors together are reflected in this value N. Okay. Whereas if you conduct this CPT test, in CPT you will note down the skin friction separately and the cone penetration, that is the tip resistance. Okay, resistance offered to the tip of this cone, you can see the tip. Okay, both these things are separately assessed. So here there is no confusion. N is representing both the things, otherwise the resistance, tip resistance and the friction, whereas here both the things are recorded separately. Okay, now what are the type of soils for which this particular test is applicable? This is applicable mostly for soft clays and silts. It's also applicable for fine to medium sand deposits. Okay, now the cone will have around 60-degree angle at the apex. Okay, it will consist of a solid sounding rod. Okay, I'll try to get a figure. So there is a solid sounding rod here, and outer mantle tube will be there. Okay, and I hope this is visible. If it's not, then I'll make it full screen. Okay, outer mantle tube is there. Then there is a friction jacket and a cone assembly. Okay, now we will understand the procedure first before we go to other points. Now what is happening in this first figure, that is position A? The cone and friction assembly, now this is the initial position, okay, before you actually start driving it into the soil. This is a position. Okay, now if you can see, I have marked this in purple. Can you see? Whatever is marked in the purple is the cone. Okay, so in position 1, the cone and the friction jacket is stationary. Okay, now position 2, you can say, actually, that is B figure, actually you are starting to drive. Now I am just reading out from your textbook, okay, whatever happens from this position B. So in this second position, the cone will be pushed into the soil deposit by the inner solid sounding rod to a depth X. Okay, so you can see only this has moved down. How much it has moved down? You can see it was earlier here, now it has gone down to this position. So it has moved down by X into the soil deposit. Now the rate of application or the rate of movement is around 20 mm per second. Okay, till the collar engages the cone, that is the friction jacket or union of sleeve, remains stationary in the motion. Okay, now till this particular cone gets fixed inside the soil, this movement will go at the rate of 20 mm per second. The force is applied hydraulically and the reaction is usually provided by means of screw anchors in the ground. Force, that is resistance QC, okay, capital QC, okay, gets recorded on a pressure gauge. Tip resistance is called Q. I'll use some other color. So the tip resistance is called QC, okay, and capital QC is the force. So now by this logic, how will you get QC? QC will be capital QC divided by AC. What will be AC? AC will be the area of the cone. Okay, and now in the position 3, what happens is solid sounding rod will be pushed further by depth Y. So earlier it had moved by X, now it is moved further by Y. Now can you see what is moving in this? In this now, this friction jacket has moved downwards. So the total movement is X plus Y. Can you see this? Okay. So now the sounding rod is moved further downwards by depth Y. Now this Y is equal to 40 mm, which pushes the friction jacket as well as the cone assembly together. The total force, now in this case you are going to measure, in this stage you are going to measure QT. That is total force required for this push again is read on the pressure gauge. This force QT is recorded now in the second step. So second step meaning this is the stationary position. No, this is the first and this is the second step. Okay, in fact, it indicates the force required to push the cone as well as friction jacket. Now, therefore, QF will be equal to QT minus QC. Okay, the side resistance that is skin friction on the jacket sleeve is then given as QF upon AF. Okay, what is this? This is the friction. Okay, where AF, what will be AF? What will be AF? Where do you experience friction? Friction will be experienced on the surface, right? So the curved surface area of this friction jacket of the cylinder, that will be AF. Now in position 4, that is shown in D, okay, the outer mantle tube is pushed downwards to a distance of X plus Y, okay, and thus bringing the cone and friction jacket to original position. Okay, so now what has happened? This full thing has moved down by X plus Y. Now when full thing moves down by X plus Y, everything is back in its position. You can see over here there was a gap, see, between the friction jacket and cone. Now when this also moves down by x plus y, now this is as good as this position. If you can see, this position D is same as position A. Full assembly, outer assembly has now moved by x plus y. So relative to each other, the movement has become 0. First what happened? Only the friction jacket moved by x. Then what happened? This thing moved by y, this top thing. First only cone moved, second the friction jacket and outer mantle moved by y. So now, and last what happened? This again full thing moved down. This outer mantle and friction jacket moved down. So total movement of this full outside casing became x plus y, and relative movement of the cone with respect to friction has become 0. That's why you can see there is no gap here. Okay, so this is as good as the stationary position. Now the only issue with this particular procedure as compared to SPT what happens, you are driving a hollow drilling rod, right? Hollow rod downward. So, and you also collect the samples. These samples can be brought to the lab and you can do further testing of this. It serves as an undisturbed sample. This is the only drawback of CPT. There is no sample collected. Okay. Now, let's go to DCPT. Now, what happens in DCPT? DCPT is dynamic cone penetration test. Now, in dynamic cone penetration test, this also has IS guidelines. Okay. Now, DCPT is either performed by using 50 mm dia cone with or without bentonite slurry, or by using 65 mm dia core with bentonite slurry. So, if you are going to increase the diameter of the borehole, bentonite slurry is mandatory. Driving will be carried out under 65 kg hammer falling at a height of 75 centimeters. This is same as SPT. And the number of blows for every 100 mm, every 10 centimeter penetration of the cone is recorded. The cone is driven till refusal or up to the required depth, and the drill rods are withdrawn, leaving cone behind in the ground. Now, what do you mean by refusal? Refusal in case of standard penetration test was if 50 blows are reached before the required penetration. What was the required penetration? We were noting down the number of blows for every 15 centimeter of penetration. Okay, sometimes even 7.5 centimeter of penetration. So let's say you have applied 50 blows and still 30 centimeter of penetration has not occurred, then we would stop it. And the actual penetration corresponding to 50 blows would be noted. This is in case of SPT. Now over here, the textbook is not giving me a very clear idea about what is refusal, but somewhere on the internet I read if the number of blows are 100, okay, and still the penetration is not around 30, okay, 30 centimeters I'm talking about, then you stop it. Okay, so number of blows, if you have given 100 blows and still the penetration is not even 30, then you consider it as refusal. Okay, number of blows required for 300, that is 30 centimeter penetration, is noted as dynamic cone resistance, that is NCD. Okay, so for 300 mm penetration, NCD will be recorded, right? The test gives continuous record of NCD with depth. Only drawback again here is no sample is collected. This test can be performed in a cased borehole if the skin friction has to be eliminated. The moment a borehole becomes cased, then you can't get the skin friction. But if the skin friction is not your primary criteria, then you can have a cased borehole and you can only note down the tip resistance. Okay. Now these are some correlations obtained. You can pause the video and check these things. Okay, value of N and QC, N by QC values, type of soil, value of N for given QC in kilonewtons. This is one correlation. Second is this correlation between NC and N. What is NCD? dynamic cone resistance, and N.